Hello all, welcome to Unacademy. Today we will going to see our first chapter on our partial differentiation, which is actually very easy, but still as it is a part of your syllabus, I will taking it. Now see how to elaborate the partial derivatives. There are different types of partial derivatives are given. Also we will see the Euler's function and Euler's function on homogeneous, and then many things are we will cover up in this lecture. So how to find out or verify the partial differential equations, or how to evaluate the partial differential equations are given. Okay, so before going to start this, let me introduce myself. Myself Dhanashree Mam. I completed my MSc in mathematics from Mumbai University, and I'm also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for engineering. Okay. See, in short, I will tell you how to evaluate the, how to install the Unacademy's learning app. First, go to your mobile's Play Store app and then search Unacademy's learning app. After that, install the Unacademy's learning app. After that, step 3, you have to manage your goal here, for which course you want to study. जैसे कि हम लोग अभी यहाँ पे GATE and ESE के लिए पढ़ रहे हैं, तो आपको यहाँ पे अपना कोर्स मैनेज करना है, और यहाँ पे आप सब्सक्रिप्शन ले सकते हैं, जैसे कि प्लस क्लासेस है, फ्री कोर्सेस है, स्पेशल क्लासेस है. You can take any subscription over here. Then take, see, after that I will tell you कितने टाइम के लिए आप लोग ये पढ़ना चाहते हो. दैट प्लान इट मीन्स फॉर विच मंथ्स और हाउ मच मंथ यू वांट टू स्टडी. सो यू कैन सिलेक्ट योर प्लान हियर. इट इज 12 मंथ्स के लिए है, 24 मंथ्स के लिए. हर एक मंथ के लिए सब्सक्रिप्शन अलग अलग है. अगर आप अपने सब्सक्रिप्शन पे 10% डिस्काउंट चाहते हो, तो देन यूज माय प्रोमो कोड, दैट इज DSP, so that you will get a 10% discount on your subscription fees. Next is, so Unacademy is launching with this is my promo code, that is DSP. You can here you can take any special class, live test series, quiz. Okay, so that you will get a here 10% discount on it. Any one of that you can choose. Then with the code DSP you can take, you can get a 10% off on that courses. I will start our actual topic, which is partial derivatives. Okay, a partial derivative of a function of a several variables is the ordinary derivatives of a function with respect to one of the variables, keeping remaining all variables as a constant. Is your partial derivative. Suppose let u is equal to f of xy be any function of two independent variables x and y. Then the partial derivative of u is equal to f of x with respect to x is the ordinary derivative of u with respect to x, keeping variable y as a constant, and it is denoted by dabba u by dabba x or dabba f by dabba x. Okay. Or ux, u suffix x, or f suffix x, and read as either dabba u by dabba x or del u by del x. Anything we can use. So here we will define partial derivatives with respect to x. Here dabba u by dabba x is equal to limit as delta x tends to 0, f of x plus delta x comma y upon delta x, provided limit exists. This is very important. If limit is not exist, then we cannot define this function. Similarly, we can define a partial derivative of y with respect to y, keeping x as a constant, and it is denoted by dabba u by dabba y or uy, or dabba f by dabba y or fy, and read as dabba u by dabba y or del y. Okay. Now dabba u by dabba x, here dabba u by dabba y is equal to f of x comma y plus delta y minus f of xy upon delta y, provided limit exists. If u is equal to f of x1 x2 up to xn, that is if u is a function of n and finite independent variables, then the partial derivative of a function u with respect to x1 is obtained by differentiating u ordinary with respect to x1, and it is obtained by differentiating u ordinarily with respect to x1 keeping all remaining variables constant, and it is denoted by u by x1 or f by x1. Now how it is defined and everything we have seen. Now higher order partial derivatives. Okay, if we differentiate is 2 times 3 times, so you will get the higher order partial derivatives. The definition is same here. This is the first order partial. If the first order partial derivatives is u by x and u by y, maybe the function of x and y, so we can differentiate partially again with respect to x as well as y. We get higher order partial derivatives such as square u by x square is equal to by x of u by x, or square f by x square is equal to by x of f by x or uxx or fxx. So this is the partial order derivative of u of order 2. Okay, we can represent by using this. Now next is square f square upon by x is equal to by y of u by x, or square f by y x is equal to by y of f by x. So जो भी यहाँ पे है first वो आएगा, so or it is denoted by uxy or fxy. So square of square upon x y is equal to by x of u by y or square f by x y, which is equal to by x of f by y or uyx or fyx. Okay. Now, square upon y square is equal to by y of u by y, or square f by y square is equal to by y of f by y or uyy or fyy, are called as the second order partial derivatives. Similarly, you will get the third order partial derivatives also. Okay, and the functions different for x, y, z. You will get the partial order derivatives with respect to x, y, z also in the similar manner. Okay, now we will solve our first example, how to elaborate the partial derivatives or how to evaluate the partial derivatives. Okay, now here is given if u is equal to 1 minus 2xy plus y square bracket raised to minus 1 by 2, then prove that x u by x minus y u by x is equal to u cube into y square. Okay. Here u is equal to 1 minus 2xy plus y square bracket raised to minus 1 by 2. Then prove that x u by x minus y u by x is equal to u cube into y square. Okay. Now we will see here how to elaborate this. First we require u by x. So we can write here u is equal to here 1 minus 2xy plus y square bracket raised to minus 1 by 2. We can find out the derivative by using ordinary differentiation, but here the variables are different x, y, anything you can get here. So first of all, differentiating u partially with respect to x, and partially then it is denoted by u by x. So differentiating u partially with respect to x as u by x is equal to u by x is equal to, now here you can treat this as your u raised to n. So minus u raised to n derivative क्या आएगा, minus n into u raised to n minus 1 into derivative of u with respect to x. Okay, so we can write here minus 1 by 2 into 1 minus 2xy plus y square bracket raised to minus 1 by 2 minus 1. So you will get here minus 1 by 2 into 1 minus 2xy plus y square bracket raised to minus 1 by 2 minus 1 is minus 3 by 2. Right? So u by x is equal to this. Now into derivative of u with respect to x. So derivative of u with respect to x हो जाएगा. Derivative of constant is 0, minus 2x square का derivative with respect to x हो जाएगा minus 2y plus 2y. right? Here minus 2y plus 2y. So minus 1 by 2 into 1 minus 2xy plus y square bracket raised to minus 3 by 2, and you will get here derivative of this function with respect to x. With respect to x you will get minus 2y, and here you will get with respect to this you will get plus minus 2y plus 0, because here with respect to x we are taking the derivative, right? Derivative of y square with respect to x here is 0. So you will get dabba u by dabba x is equal to minus 1 by 2. So 2 get cancel out. You will get minus y only. Okay. Minus y into 1 minus 2xy plus y square bracket raised to minus 3 by 2. Your dabba u by dabba x. Now we required x into dabba u by dabba x. Right? Here we required x into dabba u by dabba x. So multiplying both sides by x. So you will get x dabba u by dabba x is equal to minus xy into 1 minus xy plus y square raised to minus 1 by 2. Sorry, raised to minus 3 by 2. Okay. This is your x dabba u by dabba x. Call this as equation number 1. Okay. Now again, we require y into dabba u by dabba x. So multiplying this equation, so call this equation as a star. So multiplying equation star by y. So what you will get? Multiplying equation star by y. So y dabba u by dabba x minus y dabba u by dabba x minus is equal to minus y square is equal to minus y square into 1 minus 2xy plus y square bracket raised to minus 3 by 2. Right? So this is your equation number 2. Now we required x dabba u by dabba x minus y dabba u by dabba x. So equation 1 minus equation 2. Equation 1 minus equation 2. So you will get x dabba u by dabba x minus y dabba u by dabba x is equal to minus xy into 1 minus 2xy plus y square bracket raised to minus 3 by 2 minus minus of minus plus y square into 1 minus 2xy plus y square raised to minus 3 by 2. Right? If I take 1 minus x square 2xy plus y square common, so you will get minus xy minus y square. Right? So you will get here 1 minus 2xy plus y square bracket raised to minus 3 by 2 into bracket xy minus y square. Right? Into bracket xy minus y square. But xy minus y square is minus raised to minus 1 by 2 raised to 3. Can I write this as minus 3 by 2? So x dabba u by dabba x minus y dabba u by dabba y is equal to, if I take x common, xy into xy minus y square common. So xy minus y square into bracket. Here is 1 minus 2xy plus y square bracket raised to minus 1 by 2 raised to 3. Instead of writing 3 by 2, then raised to 3. And is it nothing but, this is nothing but our This is nothing but our take here xy minus y square. Instead of this xy minus y square, can take and common, if you are taking common here, so xy minus y square minus xy also you are getting, right? Minus xy. Y minus xy minus y square. Plus xy minus xy get cancel out, and this is minus of y square. So minus of y square comes minus minus plus, because minus minus is here. Now see, minus xy and plus y square. So you are getting here minus of y square into bracket. Now this is nothing but your q raised to minus 1 by 3. Whole thing is nothing but raised to u cube into y square. I hope you are clear here. Now see, minus y square and get the next one. If u is equal to 1 upon root of x square plus y square plus z square, then find the value of dabba square u by dabba x square plus dabba square u by dabba y square plus dabba square u by dabba z square. Okay, now here u is equal to this. So you can write here u is, you know that here u is a function of x, y and z. U is a function of x, y, z. Then we can write here dabba u by dabba x. First, we'll convert u is 1 upon root of, so x square plus y square plus z square bracket raised to minus 1 by 2. This is our u. Now we can write dabba u by dabba x is equal to minus 1 by 2 into x square plus y square plus z square bracket raised to minus 1 by 2 minus 1, that is minus 3 by 2, into derivative of x square plus y square plus z square with respect to x is 2x, right? So 2 get cancel out here. So you will get dabba u by dabba x is equal to minus x into bracket x square plus y square plus z square bracket raised to minus 3 by 2. Okay, we require dabba square u by dabba x square. So again differentiating this partially with respect to x. So again differentiating this partially with respect to x. So you will get dabba square u upon dabba x square is equal to, now here you have to apply u into v rule. So first into derivative of second, and minus, keep minus side outside. First into derivative of second हो जाएगा minus 3 by 2 into x square plus y square plus z square minus 3 by 2 plus 1. So here minus 1 by 2 into derivative of x square plus y square plus z square is 2x. First into derivative of second plus second into derivative of first. X square plus y square plus z square bracket raised to minus 3 by 2. Okay, this is your dabba square u by dabba x square. Now once you get dabba square u by dabba x square, so you can write here, simplifying manner we will write dabba square u by dabba x square is equal to, now minus minus plus, here you will get 3x by 2, and this 2 and this 2 will get cancel out. So minus 3 into x into x, so minus 3x square, and this minus sign becomes plus. So 3x square into bracket 3x square into bracket x square plus y square plus z square bracket raised to minus 1 by 2, right? Plus this minus and this minus, so you will get here minus x square plus y square plus z square bracket raised to minus 3 by 2, right? So this is our bracket raised to minus 3 by 2. Now, taking minus side outside, minus 3 by 2. So minus this minus becomes plus and raised to x, or this one becomes, now this is our dabba square u by dabba x square. So 3x square upon, you can write x square plus y square plus z square bracket raised to 1 by 2 minus 1 upon x square plus y square plus z square bracket raised to minus 3 by 2. Right? Our dabba square u by dabba x square. Now we require dabba square u by dabba y square. So exactly similar way, we'll get dabba square u by dabba x y square is equal to first into derivative of second. So minus 3 by 2. That is minus 3 by 2 minus 1 minus 5. It comes minus 5 by 2 plus 5. So plus 5 by 2 and minus 3 by 2. Here we are getting 1 upon square is equal to, we can write here 1 upon x raised to plus y raised to 2 plus z raised to 2 bracket raised to 5 by 2. Into bracket you will get 3x square minus, now 5 by 2 it's outside, so you will get here is minus 3x square, here is 3x square minus x square plus y square, x square plus y square plus z square. Okay. So ultimately you will get minus 2x square, so dabba square u upon dabba x square, we can check here. Now see the plus minus sign, minus minus plus, and this one is minus sign. Minus sign. There is plus 3 by 2 plus 3 by 2. If I take the 5 by 2 common, by 2, get 5 by 2 plus 1. So only x square plus y square plus z square is here. So 3x square minus x square, that is x square minus y square minus z square on x square plus y square plus z square bracket raised to 5 by 2. Okay. Now next, we will calculate the dabba square u by dabba z square. Okay. Similarly, you will get dabba square u by dabba y square also. So dabba square u by dabba y square is equal to x. So dabba square u, similarly we will get dabba square u by dabba y square is equal to x square minus 2y square minus z square upon x square plus y square plus z square bracket raised to 5 by 2. So dabba, similarly we'll get dabba square u by dabba z square, x square minus x square plus y square, x square minus y square minus 2z square upon x square plus y square plus z square bracket raised to 5 by 2. Okay. Now adding these three equations, so you will get, now adding 1, 2, 3. Now call this as equation number 1, equation number 2, equation number 3. So adding equation 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, Adding equation 1, 2, 3, we get, adding equation 1, 2, 3, we will get here dabba square u upon dabba x square plus dabba square u upon dabba y square plus dabba square u upon dabba z square is equal to, now see, 2x square plus x square plus x square, so it is 4x square. Okay, so here is 4x square will get wrong here. Y square minus y square where you getting here. I don't put the minus sign inside. X square plus y square minus plus 2x square, and here is minus y square minus z square. Exactly similar to 3y square. So minus x square you will get here. Minus x square plus 2y square. There is also minus x square. Here is plus 2z square. Minus z square and minus z square. Minus y square minus y square. Correct. Take 1 upon x raised to 2 plus y raised to 2 plus z raised to 5 by 2 to bracket. Take 2x square minus x square, so 0, plus 2 minus y square plus 2y square minus y square, again 0, and here is also same. So ultimately the value of this equation is, so everything, after doing everything this, we'll get answer 0. Okay, now see, if u is equal to phi of x plus ay and b is plus psi of x minus ay, then show that dabba square u upon dabba y square is equal to a square into dabba square u by dabba x square. So you will get dabba u by dabba x. So u is a function of phi and psi, and u is a function of phi and psi, and phi and psi are function of x and y, right? Phi and psi are function of x and y. So differentiating this u with partially with respect to y, because we require dabba square u by dabba y square. So differentiating u partially with respect to y, we get dabba u by dabba y is equal to, okay, so dabba u by dabba y, phi dash of x plus ay to a, right, plus psi dash of x minus a to minus a. Okay, now we'll get dabba square u by dabba y square is equal to phi dabba square u by dabba y square, so is constant, again phi double dash of x plus ay into a into that a, so you get s plus psi dash of x minus psi double dash of x minus ay into that minus a and this minus a, so it becomes a square. Okay, this is our a square into, so dabba square u by dabba y square is equal to, we will get a square common, dabba square u by dabba y square is equal to take a square common into bracket phi double dash of x plus ay plus psi double dash of x minus ay, right? Phi double dash of x minus x plus ay plus psi double dash of x minus ay. Now we will calculate dabba square u by dabba x square. So first we will calculate dabba square u by dabba x square. So again differentiating u partially with respect to x. Okay. Differentiating u partially with respect to x. So you will get dabba u by dabba x. Here dabba u by dabba x is equal to phi dash of x plus ay, and derivative of this is again x plus ay का derivative with respect to x हो जाएगा 1. Okay, plus psi dash of x minus ay, psi dash of x minus ay. Again we require differentiating dabba square u by dabba x square is equal to phi double dash of x plus ay. Again derivative of x plus ay with respect to x is 1. Psi double dash of x minus ay. Phi double dash of x plus ay plus psi double dash of x minus ay. Okay. Now this is your dabba square u by dabba x square. So we will get here from equation 1 and from equation 2. If you see here, this is nothing but your dabba square u by dabba x square. So we can write directly dabba square u by dabba y square is equal to a square into bracket dabba square u by dabba x square. Or you can write here a square into bracket phi double dash of ay x plus ay plus psi double dash of x minus ay. Okay, but this is nothing but your dabba square u by dabba x square. A square into dabba square u by dabba x square. Okay. Now next example, if u is equal to e raised to x plus y plus z upon e raised to x plus e raised to y plus e raised to z, then find the value of. सिंपल डेरिवेटिव है, जस्ट ऐड करना है u को with respect to x y z से differentiate करना है partially and then add it. Okay, so it's a very simple. We will find out dabba u by dabba x first. So u upon v rule, because both are functions of x and y, numerator and denominator as well as. So here you will get differential equation of dabba u by dabba x is equal to, you will get v du e raised to x plus e raised to y plus e raised to z into derivative of e raised to x plus y plus z is e raised to x plus y plus z, right? So v into derivative of this, again the derivative with respect to x 1 ही आ जाएगा x plus y plus z minus v du minus u dv x plus y plus z into derivative of e raised to x with respect to x e raised to x upon e square. So e raised to x plus e raised to y plus e raised to z bracket square, right? Call this as equation number 1. Now similarly dabba u by dabba y. So you will get e raised to x plus e raised to y plus e raised to z into e raised to x plus y plus z minus e raised to x plus y plus z into e raised to y upon e raised to x plus e raised to y plus e raised to z bracket square. Call this as equation number 2. Right? Now, dabba u by dabba y. Now, dabba u by dabba y. Here you will get dabba u by dabba z. So, e raised to x plus e raised to y plus e raised to z into e raised to x plus y plus z minus e raised to x plus y plus z into e raised to z upon e raised to x plus e raised to y plus e raised to z bracket square. All this is equation number 3. So adding all these equations, adding all these three equations, so w by w x plus w by w y plus w by w z. So w by w x क्या है हमारा e raised to x plus y plus z कॉमन लेते हैं है ना e raised to x plus y plus z into bracket e raised to x plus e raised to y plus e raised to z e raised to x plus e raised to y plus e raised to z minus e raised to x, right, upon e raised to x plus y plus z bracket square. No. Now, if you observe here, plus e raised to x minus e raised to x cancel out. So, e raised to x plus y plus z. So, this one and this one becomes cancel out. So, here you will get e raised to y plus e raised to z upon e raised to x plus y plus z. Right? Plus, 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 plus. Then you will take e raised to x plus y plus z common. E raised to x plus e raised to y plus e raised to z minus e raised to y upon e raised to x plus y plus z bracket square plus x plus y plus z into e raised to x plus e raised to y plus e raised to z minus e raised to z upon e raised to x plus y plus z bracket square. This one becomes cancel out. This is also cancel out. Now this is cancel out. This one is cancel out. This is cancel out. This one cancel out. We'll get here e raised to y plus e raised to z plus e raised to x plus e raised to z plus e raised to x plus e raised to y upon e raised to x plus y plus z. So is it nothing but 2 into bracket e raised to x plus e raised to y plus e raised to z 2 e raised to x 2 e raised to y 2 e raised to z upon e raised to x plus y plus z. Right? Is your final answer and is it nothing but your u which is equal to 2u. So w by wx plus w by wy plus w by wz is equal to 2u. Okay. Now next one. Now the examples of verification of w square u by wx y. If u is equal to x cube plus y plus e raised to xy square, then prove that w square u by wx square u by wx y is equal to w square u by y wx. So first we will calculate. Consider w square u by wx y which is equal to w by wx of w by y is equal to w by wx of. So first we will calculate u by y. So you will get x cube e raised to into derivative of xy square with respect to y. Okay, to xy. Right? E raised to u into derivative of u. So this is your u by y. Now calculate w square u by x y. Now differentiating this partially with respect to x. So 3x square plus here u into v rule apply. First into derivative of second with respect to x. So that is 2y plus second into derivative of first. Derivative of first e raised to xy square with respect to x है, तो xy square का derivative हो जाएगा y square and into 2xy. So 3x square plus e raised to xy square into 2y plus e raised to xy square into 2xy cube, right? To 2xy cube. So you will get here 3x square 3x square plus 2xy cube into e raised to xy square plus 2y e raised to xy square. Okay. Now we will calculate dabba square u by dabba y dabba x. First calculate dabba u by dabba x. So here u is equal to your u is equal to x cube y plus e raised to xy square. X cube y plus e raised to xy square. Right? So we'll calculate dabba u by dabba y first. Dabba u by dabba x first. So 3x square y plus e raised to xy square into derivative of xy square with respect to x is y square. Then dabba square u by dabba y dabba x is equal to 3x square plus u into v rule. First into derivative of second plus second to derivative of first. Derivative of first with respect to y square 2x to y square. Dabba square u by dabba y dabba x is equal to 3x square plus e raised to xy square into 2y plus e raised to xy square into 2xy cube. To observe, the first dabba square u by dabba x dabba y, call this as equation number 1 and this as a your equation number 2. Equation number 1 and equation 2. From 1 and 2, dabba square u by dabba x dabba y same as dabba square u by dabba y dabba x. That's want to prove. Now if u is equal to x raised to y plus y raised to x, u is equal to x raised to y plus y raised to x, then prove that dabba square u upon dabba x dabba y is equal to dabba square u upon dabba y dabba x, right? So here x is equal to u is equal to this, so calculate first dabba u by dabba y. So differentiating u partially with respect to y. So here x raised to y. Okay. So how we can differentiate this x raised to y? So u is a function of x and y. So here you will get x raised to y, it means a raised to x. So a raised to x into log a. But here a is equal to x. So x raised to y into log x plus. Here differentiating y partially with respect to y. So x raised to n cases n into x raised to n minus 1. Right? So this is your dabba u by dabba y. Now calculate dabba square u by dabba x dabba y. Right? So u into v rule. Differentiating partially with respect to x. So first into derivative of second. The second into derivative of first. So derivative of first, so y into x raised to y minus 1 into log x. Right? y x raised to y minus 1 into log x. So ultimately you will get here x raised to y minus 1 plus y into x raised to y minus 1 into log x. We'll get here x raised to y minus 1 common 1 plus y log x. We call this as equation number 1. Dabba square u by dabba x dabba y. Okay. Now next, calculate dabba u by dabba x first. Is equal to, here your u is equal to x raised to y plus y raised to x. Raised to y plus y raised to x. Calculate dabba u by dabba x is equal to, differentiating this partially with respect to x. So you will get y into x raised to y minus 1 plus with respect to, so y raised to x into log y. Now differentiating partially with respect to y. So u into v rule. First into derivative of second. So y into y minus 1. Okay. Here a raised to x cases. X raised to y minus 1 into log x. A raised to x, because keeping x as a constant. First into derivative of second plus second into derivative of first plus differentiating this partially with respect to y. Again u into v rule. So first into derivative of second so you can write here first into derivative of second. So first is y raised to x to derivative of second 1 upon y plus second into derivative of first. So x into y raised to x minus 1 into log y. So ultimately here x raised to y minus 1 common. Log x plus 1 plus raised to x minus 1 plus x into y raised to x minus 1 into log y. So x raised to y minus 1 y log x plus 1 into y raised to x minus 1 common plus x log y, right? Plus x log y. You observe think we didn't do the part here. X raised to y first into derivative of second plus second into derivative of, then we didn't run first into with respect to x, now first into derivative of second. So derivative of second a raised to x, so a raised to log y. The second into derivative of first y raised to x minus 1. So here you will get plus y raised to x minus 1 common x log y. So plus here y raised to plus here y raised to x minus 1 into bracket x log x plus 1. If you observe first and second, first your second, so both are equal. Okay, from 1 and 2. So from 1 and 2 you will get the both are equal. Okay. Now next example we will see. U is equal to log of x square plus y square. Then show that dabba square u by dabba x dabba y is equal to dabba square u by dabba y dabba x. Okay, so u is equal to this. So calculate dabba u by dabba y first. So dabba square u by dabba x dabba y, it means dabba by dabba x of dabba u by dabba y is equal to, here first calculate dabba u by dabba y. Dabba u by dabba y, log u 1 upon u into derivative of u with respect to y, that is 2y, 2y upon x square plus y square. Then dabba square u by dabba x dabba y equal to dabba y. Now here 2y is constant, right? So 1 upon x square plus y square is minus 1 upon x square plus y square bracket square into derivative of x square plus y square with respect to x, that is 2xy. So here you will get into xy, right? Get here y upon x square plus y square. Now differentiating again. So we will get 2y into minus 1 upon x square y square and plus into derivative 2x. We get minus 4xy upon x square plus y square bracket square. Square plus y square bracket square. So this is your equation number 1. Now calculate dabba u by dabba x first. Dabba u by dabba x. So first of all we write here u again is equal to log of x square plus y square. Log of x square plus y square. Now calculate dabba square u upon dabba y dabba x. So dabba square u upon dabba y dabba x. So first calculate dabba u by dabba x. So dabba u by dabba x is equal to 1 upon x square plus y square into derivative of this, that is 2x. Now calculate dabba square u by dabba y dabba x. Differentiating this partially with respect to y. 2x as it is into minus 1 upon x square plus y square bracket square into derivative of x square plus y square with respect to y, that is 2y. So again you will get minus 4xy upon x square plus y square bracket square. So dabba square u by dabba y dabba x is equal to this. Now if you observe from 1 and 2, from 1 and 2, it is given from 1 and 2, we'll get dabba square u by dabba y dabba x is equal to dabba square u by dabba x dabba y. Okay, that's it. Now see, if u is equal to tan inverse of x by y, then prove that dabba square u by dabba x dabba y is equal to dabba square u by dabba y dabba x. Okay, so first we will calculate dabba u by dabba y. Consider dabba square u by dabba x dabba y, which is equal to dabba by dabba x of dabba u by dabba y. Now dabba u by dabba y, so tan inverse x ka derivative, tan inverse u 1 upon 1 plus x square, right? So dabba u by dabba y is equal to 1 upon plus x square, that is x plus y brackets into derivative of u, x plus y ka derivative with respect to y. So that is minus, here you will get derivative of u with respect to y is minus 1 upon y square, minus x upon y square. So dabba u by dabba y. Okay. Now we'll calculate dabba square u by dabba x dabba y is equal to, right, dabba square. So ultimately here is 1 upon x square plus y square upon y square. So हो जाएगा y square to minus x upon y square. So is it nothing but y square cancel out, minus x upon x square plus y square, right? Minus x upon x square plus y square. Now calculate daba u by daba square u by daba x daba y. So daba square u by daba x daba y is equal to, we'll get differentiating this partially with respect to x, so u upon v. So v du minus 1 and keep minus sign outside. Okay. V into derivative of u minus u into derivative of v, that is 2x square plus square bracket. So here is minus 2x square plus y square minus 2x square plus x square minus x square and this minus sign. So it will becomes x square upon x square plus y square bracket square. Okay. This is your daba square u by daba x daba y. Now daba square u by daba x daba y. Now we will find out daba square u by daba y daba x. U is equal to tan inverse of y by x. X by y. Calculate first daba u by daba x. Right? Calculate first daba u by daba x. 1 upon 1 plus x square x by y bracket square into derivative of x by y with respect to x, that is 1 upon equal to 1 upon 1 plus x square by y square to 1 upon y. So x square plus y square upon y square. So y cancel out. So y upon x square plus y. Y upon x square plus y square. So daba u by daba x is equal to this. So daba square u by daba y daba x is equal to. So v du. Derivative of y is with respect to y is 1 minus u dv plus u derivative of this, that is 2y on v square. X square plus y square bracket square. Get here x square plus y square minus 2y square minus y square plus y square minus 2y square plus y square, so minus y square upon x square plus y square bracket square. That is plus y square square minus y square and plus ultimately here is x square minus y square upon x square plus y square brackets. Hope you are clear here how to find out the partial derivatives when the functions are given. Okay, there are many types. You can solve the similar type also. Some particular example. This is very interesting example. U is equal to x square plus y square by x plus y. Then show that daba u by daba x minus daba u by daba y is equal to 1 minus daba u by daba x minus daba u by daba y. Okay. There is 1 minus, not 1 minus only, here is 4 into 1 minus. Right? So here you will get 4 into 1 minus daba u by daba x minus daba u by daba y. You can calculate this. So u is the function of x and y. First of all, calculate daba u by daba x. and w by y, then subtract and then take square on both sides. So w by x is equal to v du, derivative of this, that is 2x, 2 dv plus y with x is, and x plus y bracket square. So 2x square plus 2xy minus x square minus y square. 2x square minus x square plus 2xy and minus y square upon x plus y bracket square. Y bracket square. So x square minus x. Yes. Now calculate w by y. So x plus y minus square plus y square upon x plus y bracket square. 2xy plus 2y square minus x square minus y square. 2y square minus y square plus y square. So y square minus x square plus 2xy upon x plus y bracket square. Right? So consider w by x minus w by y is equal to x square plus 2xy minus y square minus my x square plus y square minus 2xy upon x plus y bracket square plus x square 2x square minus 2y square cancel out. So 2x square minus 2y square upon x plus y bracket square. 2x square minus y square upon x plus y bracket square. W by x minus w by y is equal to 2 into bracket x square minus y square. To bracket x square minus y square upon plus y bracket square is equal to 2 into x minus y into x plus y. A square minus b square, a plus b, a minus b. 2 into x minus y upon x plus y. Right? 2 into x minus y upon x plus y. This is called w by x minus w by y. Now taking square on both sides. So w by x minus w by y bracket square is equal to 2 into taking square on both sides. So 4 into bracket x minus y upon x plus y brackets. Right? This is our LHS. Now we can consider our RHS. Our LHS. So we will take the RHS. RHS part is here 1 minus w by x minus w by y. And right here RHS is equal to 1 minus w by x, x square minus y square plus 2xy square plus y square minus 2xy upon x plus y bracket square minus y square minus x square plus 2xy upon x plus y bracket square. Right? So you will get here 4 times to bracket 4 times into bracket 1 minus, here we can get x square plus y square plus y bracket square minus x square plus y square minus 2xy minus y square plus x square minus 2xy. Now I can explain here x plus y bracket square, that is x square plus y square plus 2xy. Right? Upon x plus y bracket square. X plus y bracket square. Plus 2xy minus 2xy cancel out. X square cancel out. Plus y square minus y square cancel out. So you will get x square minus 2xy plus y square upon x plus y bracket square. Okay, so is it nothing but 4 into bracket, so which is equal to 4 into bracket x minus y bracket square, right, upon x plus y bracket square. Okay, so 4 into bracket this, so hence from this equation it is clear that w by w x here. Check w by w x bracket square is equal to this star from double star nothing but our, and write this equation is same as 4 bracket x minus y upon x plus y brackets. Okay, complete of proof here. So in next lecture we will see our total derivatives and examples on Euler's homogeneous theorem, Euler's function or homogeneous theorem. Okay. Thank you so much. If you liking my videos, please do like, share and subscribe. Thanks a lot.